So in the previous part, you saw that we created EKS cluster and connected node group to it, doing all of these steps manually. So we basically created the necessary rows, we created the EKS cluster, we configured everything, we also created the VPC, and so on. And all these steps obviously took some time, and it's also pretty difficult to replicate. So for example, if I needed the same exact cluster environment for maybe staging and production, so I wanted to replicate the same cluster, I would have to repeat all these steps manually, which is obviously very inefficient. Now, there are different ways of creating EKS cluster. For example, we could do it using AWS command line, but we, again, would still have to create all these roles, create the VPC and EKS cluster, and so on. And one of the easiest ways is actually using a command line tool specifically made for creating EKS cluster, which is called EKS control. So just like we have kube control for Kubernetes cluster, we have EKS control for creating the Kubernetes cluster on EKS. And the reason why this is a much easier way of creating EKS cluster is because we don't have to create all these roles and VPCs and all this stuff beforehand. We basically just execute a command on our command line and everything gets created and configured in the background. Obviously using the default behavior that is already set, but as long as we don't want to change the defaults, we can just use that command. And on the command, we can actually pass multiple options for version of the Kubernetes, which region we want to create the cluster in, which EC2 types we want to use, how many instances we want, whether we want a node group for the cluster or Fargate, etc. So we have all these options for this EKS control command that we can configure and pass as parameters in order to customize these defaults, which is still way more efficient because it's just still one command. So let's actually go ahead and create an EKS cluster using EKS control command line tool. First of all, I am in my AWS account, which is empty. We have deleted the EKS cluster, so I have no EC2 instances running. And I do not have an EKS cluster. Let's check that as well. So no EKS clusters. And also all the roles that we had created previously are also gone. So we're starting completely from a clean state. So no EKS custom roles here. So the first thing we need to do to use EKS control is obviously to install the command line tool. And on Mac OS, it's pretty simple using a brew package manager. So go ahead and install EKS control. So that's the first step. When we have EKS control command line tool installed, then we have to configure the AWS credentials. Now, just like we needed to configure AWS credentials in order to use AWS command line interface, we have to do the same for EKS control, because obviously EKS control needs to use some credentials of AWS user in order to create the cluster, and the user should have all the necessary permissions. So I'm using the admin user that we have created in AWS module, and we have also configured its credentials locally in AWS configure. So in your home folder, you should have .aws folder, and inside a config and credentials files that basically contain your credentials and configuration like region and profile. So EKS control installed, credentials for admin user of AWS account configured. Now we can go ahead and execute EKS control command, which is pretty intuitive and easy. EKS control, create cluster. That's basically the command. If we execute this, it will just go ahead and take all the default values and create a cluster for us. However, we want to override some of the information. First of all, we want to set our custom name for the cluster. Let's call it demo cluster. Then we have Kubernetes version. Then we have the region. Just like when we created the cluster manually, I'm gonna set it to the same region. And then we have node group configuration. So node group name. And I'm gonna call it demo nodes. Then we have the EC2 instance type, which we also configured when we created the node group. So basically we're choosing which type the EC2 instances will be of. Let's go ahead and choose T2 micro. You can choose something else. And then we decide how many nodes we want. This is the desired number of nodes. And then we have these nodes min and node max, which is basically what you already know. This is the minimum and maximum number of nodes we want to be always available. So we limit the minimum and maximum in a cluster for autoscaler. Remember, autoscaler is not created by EKS cluster automatically. It needs some configuration, and we're gonna see that when we create a cluster. So let's set nodes min to 1 and nodes max to 3. And let's actually leave it at that. This is our command with all the options. There are some other options that we can also use. For example, you can pass your own public SSH key, which will be used in all the nodes that get created. So you can SSH with your own public key to all of the worker nodes and some other options. Another thing you have to know is that with EKS control, you can also create a config file in the same format as Kubernetes configuration files. So you can create a YAML file which has all of these options defined, and then you can pass that file to EKS control. So if I go to the documentation of EKS control, here you have a lot of different options that you can check out for different configurations for your cluster. So for example, EKS manage node groups, Fargate support, fully private cluster, etc. So let's actually check one of those. And you also have the example YAML file with a bunch of configuration. So just like you saw setting some options for the EKS control command, you can basically set these values in a YAML format and pass that file as a config for creating the cluster. And obviously the advantage of using a YAML file is you're going to have a history of what you've created, so you can just basically repeat it instead of just saving the command somewhere. And also, if the configuration gets really complex and big, it's actually way easier to define it in a YAML file. So this is an option for EKS control. And you will see lots of these YAML file examples in the documentation. And another thing that I want to mention about EKS control is that it's not just for creating the EKS cluster. It's actually for managing and configuring cluster even after it's created. So we can upgrade, we can add nodes, we can change node group, we can add Fargate profiles, etc. So it's actually for managing the whole cluster rather than for just creating it. In our case, we're going to go with this simple example because we actually want to see the defaults because this is just a demo. So I'm going to execute this command and let's see what gets created. You see a bunch of output here. So as you see, a default AMI is chosen for the EC2 instances, which we didn't specify here, but it is a default. You also see the subnets in 3 different availability zones in the region that we specified. Now this command is going to take some time because obviously it has to spin up the cluster or compute resources in AWS managed account where the control plane nodes are going to run. So it needs to create all these roles, assign them to respective services, and so on. It needs to create the node group and the underlying EC2 instances, which then should have container runtime and Kubernetes processes installed on them. So all of this obviously takes some time. So it may be up to half an hour until the cluster is fully up and running. So as you see, the cluster was created. We have a bunch of output here, deploying the demo cluster, deploying node group stack demo nodes. Also, the kube config got automatically configured and saved locally in my user folder in .kube/config. So basically, kubectl is already configured to talk to that newly created EKS cluster. So in case I had something here before, for example, old cluster configuration, now kubectl is going to be configured to talk to the new cluster. And the demo cluster is ready. So now if I do kubectl get nodes, for example, here you see the two nodes that we specified as desired number, and both of them have the region name as well in the name and the IP addresses. And we've also specified the version in the config. So that's the version of Kubernetes processes they are running. And obviously the cluster is empty, so we don't have any pods yet. Now it's interesting to see what actually got created under the scenes in our AWS account. So let's go to AWS Management Console. And first let's check the roles in IAM. Here you see that new roles got added. You see, first of all, the EKS control demo cluster node group role. Let's check the permissions for this one or the policies. And this is basically the node group role that we manually created before. So it got automatically created. Then we have the cluster service role, which has a cluster policy. This is the cluster role that we basically give the AWS managed account permission to do stuff in our AWS account. We have a similar AWS managed policy here, which lets AWS manage some of the EKS network resources on our behalf as well. Plus some of the additional policies that got created, so not AWS managed policies. You see by the names that these policies have been created additionally. Elastic Load Balancer permission and CloudWatch permission. So these are new. We didn't create those last time. And then we have access to those two roles by the cluster. So basically, this is the autoscaling role and Amazon EKS role, service role. So note here that EKS actually does a lot of stuff by default in the background, configuring some of the additional stuff that we didn't configure the last time. That's where we're going to see some minor differences. So these were the roles. Now let's actually go and check the VPCs. So as you see, an additional VPC got created. One is the default one that you have available in a region by default. And this is the one that just got created by EKS control. And you see the name, the prefix here as well, is EKS control demo cluster VPC. And we're going to see some additional information. For example, the IP range that the VPC will have available. So the Kubernetes pods, services, etc. will get the IP addresses from this range. And if I go to the subnets, you're going to see, let's actually filter this EKS control. First of all, each has a subset of IP address ranges from the VPC. As you see right here, we have two subnets running in each AZ or availability zone. And the reason is because in each AZ, just like we did before, previously, a public and private subnet pair gets created. So if we check the list of subnets, you see for each AZ, the name shows subnet private and subnet public in each of the three availability zones. So it's the same configuration. And now let's actually check the EKS itself. So here we have the demo cluster that just got created, and let's see the configuration inside. And here you see our 2 nodes are listed right here. These are actually EC2 instances in our own account. So 2 instances are running from demo cluster. So in the EKS cluster nodes, the control plane nodes are running on the AWS managed account. So we don't see them here. What we see are the 2 worker nodes that are running on 2 T2 micro EC2 instances, and workloads basically tells us what processes are running on those worker nodes. So on the nodes, we have core DNS, AWS node, and kubeproxy processes. So these 2 are Kubernetes processes that are necessary to run scheduled pods, to configure services, etc. And this is the AWS process that lets the worker nodes communicate with the control plane nodes on the AWS account. And here we have some other details, including the cluster API server, which is the public endpoint of our EKS cluster. And that's it.